Okay, video 4, page 4. Inverses. This table shows the values of an invertible function y equals f of x. For selected values of x, create an input-output table that describes f inverse. So f inverse, that table is going to look. So 1, 2, 3, 4, 1, 2, 3, 4. So we'll have x, and we'll have f inverse of x. So we literally just swap x and y. So negative 2, 1 becomes 1, negative 2. 1, 6 becomes 6, 1, and 2, 2. They flip. And this is negative 3 and 5. If you want to be extra thorough, you could put the x values in order, because that's usually how we write them anyway. So you could put negative 3, 1, what's the next one? 2 and 6. And so then negative 3 is paired with 5, 1 is paired with negative 2, 2 is paired with 2, and 6 is paired with 1. So either one of these is totally fine. Usually put the x values in order, so we'll stick with that. If there's multiple choice on a test, it usually rearranges our x values. The graph here is f of y of f of x is given. Which of the following is the graph of y inverse, or f of f inverse? So usually what I do is I pick a point and see if any of the graphs have that point. So let's pick, this point is pretty easy to see. This is 2, 10. So 2, 10 is on the graph, which means that 10, 2 needs to be on the graph down here. So this 10, 2 is definitely not on the graph here, so it's not this one. Those aren't even the same shape. 10, 2 definitely isn't on this graph here. 10, 2 is definitely not on this graph here. 10, 2 is right there. That is on that graph, so this is the only one that it could be. Oh, I'm off the page. There we go. That's the only one it could be. Okay, those two problems went really quick, so I'm going to put them all onto, do these last ones on this video as well. So the graph of this piecewise linear function f is shown in the figure. Let g be the inverse function of s. What's the minimum value of g? Okay, so this one here. There are a couple easy ways to do this. Let's look at first. We could do this entire thing right here, but let's look at f of x, and let's look at the domain of f of x. So the domain of f of x is from negative 3 to positive 3. And the range of f of x is from negative 4 all the way up to 2. Now the range by definition is this is the lowest y value, this is the highest y value. So this is the maximum. Nope, sorry, wrong end. This is the minimum y of f. And this right here is the maximum y of f. Now let's compare it with f inverse of x. So with f inverse, the range, every x and y swap. So the domain becomes the range. So my range becomes negative 3, positive 3. My domain is negative 4 to 2. This was the minimum y value of f, but because all x and y swap, this now becomes the minimum x value of f inverse and the maximum x value of f inverse. So the range is now our new minimum. This was the minimum x, and it becomes now our minimum y. So this is the minimum y value of f inverse, negative 3. Hang on 1 second, got a cough. Sorry. Sorry about that. This is the minimum y value here, and this is the maximum y value. And it wants the minimum value of g, which is the inverse of f, so that should be -3. A lot of people make the mistake of just, since this is the minimum of f, they'll just swap these two, but it doesn't work like that. The characteristics of the graph don't swap as well, just the x and y. So if something's describing the y, it's now describing the x. Same characteristics, just different letter. This one here, I think I got this one wrong on the answer key that I uploaded, so let me just walk through it again. So this one is filling up a backdoor kiddie pool with a water hose. The amount of water in gallons in the pool after t minutes he turns the water can be modeled by p. So p is an increasing function of f, of time. So I have a second color highlighter. Doesn't look like I do, so we'll use pens. So p is an increasing function of time. Okay. So, and time is also increasing as well. So y is increasing and x is increasing because that's what time does. It increases. Now, we need to figure out which of the following is a verbal representation for p inverse. So what happens with p inverse? So p inverse, make that black. P inverse is going to take this time here. So P is a function, is a function of and then this is really water. P is water. Of water. So time of water. So the height of the water. We're swapping the units of measurement as well. So let's see which one of those kind of describes that. P is a function. So P is a function of the amount of time. No, that's regular. So it's a function. It's not a function of time like this one, so it shouldn't be this. P is a function of the amount of time. Nope, that's the same thing. So it should be C or D. It's a function of the amount of water because it's not a function of time anymore. That's swapped. This is P is the amount of water swapped with time. So time switched to water. So it should be a function of the water. Now, is it increasing or decreasing? Well, P was increasing. So here, when we look at, if we look at what the y values are doing, so the y value, sorry, yeah, these are the y values are increasing. It's an increasing function that tells us the y values are increasing. So when the y values become x, it tells us the x values are increasing. So x values are increasing, which is fine. That just means the water's getting filled up. But we care about the y values of P inverse. Now the y values, that used to be our x values, and time is increasing. As time passes, the amount of time increases. So our y value should also stay increasing. So this should be an increasing function of the amount of water in the pool. So it should be 20. It should be C. There's a possibility I selected A on mine. I wasn't reading it properly, but it should be C. Okay, next up, last one, calculator one. I don't have my. I got a calculator. We can do this. So let f be an increasing function for x's. So f is some function. Oh, here it is right here. This is f. The table gives the values of x at selected values, and the function g is given by this rational function. Find the function h is defined by h of x equals, these notations are different notation, means the same thing, so I'm just going to use this one because that's the one I like better. Find the value of h of 2. So h of 2 is equal to, h of 2 is going to be equal to g of f of 2. Since x is 2, we'll just plug that in, place that. So now f of 2 is equal to negative 10, right there. Okay, so we need to figure out g of negative 10. So we plug that in to this monster right here, and we'll get negative 10 to the 4th plus 16 times negative 10 to the 3rd plus 50 all over negative 10 minus 2. So let's plug that into our calculator. Let's read a fraction, and we will do negative 10 to the 4th plus 16x, which is negative 10, negative 10 to the 3rd plus 50, all over negative 10 minus 2. And we get that right there. Make sure that looks right. Negative 10 minus 2. Yep. So, make sure I typed everything in correctly just so for my own well-being, peace of mind. Okay. And we want the decimal approximation of it. So we will hit math. No, it's already a fraction. Math. Change it to a decimal. So it's going to be 495.833. There we go. Next, find the value of f inverse of 1 or indicate that it's not defined. So this means that f inverse of 1. So this is asking us for the y value. So we know that f of some number is equal to 1. So we want the y value. When y is 1, this is 4. So f inverse of 1 should be 4. And there we go. Okay, I will get these uploaded, and I will see y'all tomorrow.